Today we're talking about inequalities and their graphs. This is the start of our third unit. We're going to talk about inequalities for the entirety of this unit. You will have a quiz on Friday on this stuff and what we cover on Wednesday. So an inequality is a mathematical sentence that uses an inequality symbol to compare the values of two expressions. So we have less than or equal to, greater than or equal to, and not equal to. Well, let's talk about what those mean. Less than is your little alligator looking thing that everything is smaller than it. And then greater than is where it's greater than, little alligator thing just facing the other way. Less than or equal to is your less than symbol, but this time it has a line under it for the equal to part. Same with the greater than. For equal to, it's a greater than symbol with a line under it. Also, not equal to is your equal sign, your normal equal sign, but it has a line through it. So we don't like, it means it doesn't ever equal. So if you think about it, 6 is not equal to 7. All right, so let's do some examples. So we need to determine if these inequalities are true or false. So 3 plus 2 is 5. And then it says it's greater than 7 minus 3 is 4. So this is true because 5 is greater than 4. All right, let's move on to B. Negative 8 plus 3 is negative 5. And then it's less than or equal to 3 minus 8 is negative 5. So this is a true statement only because, helps if I can write, only because that equal to. If that equal to wasn't there, it wouldn't be true. All right, then we have 5 plus 6 is 11, greater than or equal to 10 plus 2 is 12. This is not true, so I draw a line through it, and I also write it's false. So that's our first false one. So 9 plus 4 is 13, less than or equal, just kidding, less than. Also, this S doesn't need to be here, so just ignore that S. I don't know why it's there. I guess I got happy when I was typing. 6 plus 1 is 7, plus 6 is 13. This is a false statement because 13 is not less than 13 because there's no equal to. If there was an equal to on the bottom, we'd be fine, but there's not. So we're not fine. We got to do something about that. All right. Now we're going to write these algebraic expressions. We're going to write algebraic expressions for these verbal expressions. So the sum of x and 16 is greater than or equal to 32. Well, sum means plus, so x and 16, and then 32. Greater than or equal to, greater than, and then equal to. The product of 13 and x is less than 36, so product is multiplying. So 13x less than 36. The difference of x and 9 is greater than 21. So difference is subtraction. X minus 9 greater than 21. And the ratio, y'all don't like the ratio, but it means it's a fraction, so, or division, x and 4 is less than or equal to 15. So the solution of an inequality is any number that produces a true statement when it is substituted for the variable in the inequality. So basically, what we're going to do is we're going to plug in, for this example, we're going to plug in 6 because it's asking me if 6 is a solution for each of these inequalities. So 2 times 6 minus 3 is less than 8. 2 times 6 is 12. Minus 3 is 9. 9 is not less than 8, so it's not a solution. Then I have 6 minus 5 greater than or equal to 1. Well, 6 minus 5 is 1. Greater than or equal to 1. So this case it is a solution because it has that equal to. And then I have 6 plus 6 is greater than 11. Well, 6 plus 6 is 12. Greater than 11. That works. So 6 is a solution there. And I have 12 plus 6 less than or equal to 17. So 12 plus 6 is 18, less than or equal to 17. That does not work because 18 is not less than 17. So those are like equations we did before where we just plugged it in and see if it worked. All right, this is kind of a different part. So graphing an inequality we use is the set of points on a number line that represents all solutions of the inequality. So open circles are when they don't have the equal to, and closed circles are when they have the equal to. So we are going to graph some inequalities here. So I am going to use, what color? Let's use purple. Pink, purple, whatever color this is. So it says x is less than negative 5. So there's no equal to, so I'm going to put an open circle around negative 5, and x is less than it, so I'm going to shade to the left. Typically, you can shade whichever way the little arrow looking thing, quote unquote, is pointing, as long as your variable is on the left. However, it doesn't always work that way. So don't quote me on that every time. So B says x is greater than or equal to 3. So greater than or equal to is a closed circle. Maybe. That's really nice looking. So greater than or equal to 3. Everything greater than or equal to 3. C says x is greater than negative 4. So put an open circle on negative 4, and I'm going to shade this way to the right because everything greater than it. And then D says x is less than or equal to 8. So put a closed circle on 8, and I'm going to shade to the left because it's less than. All right, now we got a graph, and we got to write the inequality. So we have something on 4. We have a closed circle on 4, so it's going to have that equal to. So let's just use x because x is a nice variable we like. So everything is less than 4. X is less than or equal to 4. Now for this one, we still have 4. Let's say we still have x, but there's an open circle this time, and it's greater than 4 because it's shaded on 5 and 6, which are greater than 4. Then we have a really big number because why not? 556, and we have x. And is 555 less than or greater than 556? Well, less than. So it's an open circle, so I'm going to shade it that way. Let me draw my inequality that way. Sorry, we're not shading. They're already shaded. Then I have negative 14. This one is a little complicated because it's a negative. So negative 14, and then I'm going negative 13, negative 12, negative 11. Those are greater than negative 14, so it's greater than or equal to because of that closed circle. Questions, comments, concerns, please come see me.